Okay. So probability of any event is calculated. Is right in the numerator. I'm telling you, number of favorable equally likely outcomes
Sir?
Yes.
Oh, I thought your screen is lagging. Sir, what did you say?
I said number of favorable equally likely outcomes. This will come in the numerator. Harsh, you there? Hello, Harsh.
Yes, sir.
Yeah, Harsh, can you hear me?
Yeah, I can hear you, sir.
Okay, so Harsh, we are starting with the probability chapter, right? I'm just making you people write the formula for calculating the probability. So
Okay.
the formula for calculating the probability is in the numerator, you'll write number of favorable equally likely outcomes. When you finish writing, let me know.
And sir, what's in the denominator?
Total number of equally likely outcomes. Hello?
Yes, sir.
Yeah, we will finish copying.
Yes, sir.
Okay, okay. Now, let's start with types of events, okay, that may occur in the probability part. Now, there is something, it's a bit lengthy, but please copy it as fast as you can, and then I'll explain it and solve a question with you people. Wait. I've shared it on the group. Once you finish, just drop me a text when you are done, okay?
So what do we do in that question? Sir, I'm done.
Okay, and what about Hijra? You done?
Yes, sir, I'm done.
Okay, there's a question. The question says, you people can make pointers, okay? But I'll solve it for you. Okay. The question is the probability of rain on any particular day is 0.2. The probability of rain is 0.2. That means probability of no rain will be 0.8. Okay. It is on how many days is rain not expected in a year of 365 days? Now comes the trial and expectation. Trial and expectation, the formula for it, n times probability of any event. Okay. What it says is rain not expected. That means n is 365, not expected is 0.8. So this makes up to 292 days. That means 292 days out of 365 are the days where rain is not expected to occur. Got my point?
Yes, sir.
Okay. Now give the heading mutually exclusive events and additional law. Now,
Sir, mutually exclusive events and
additional law. Addition law, sorry. Addition law. Okay. Now, what are mutually exclusive events? See, two events, two or more events are called mutually exclusive when they are not able to happen at the same time. Hmm? So, how do we identify in exam whether it's a mutually exclusive or not? If such words are being used, either or, okay, then these events are called mutually exclusive.
sir, can you repeat the definition of mutually exclusive events?
When two or more events are not likely to occur at the same time, copied, Ezra, I'm waiting for you.
Oh, yes, sir, I'm done.
Okay. Let's take the example, okay? Uh, let's say, Harsh, you listening?
Yeah, I'm sir.
Okay. Suppose I have the option to purchase a PlayStation or Xbox, okay? And if I say, okay, you can either listen to my words, okay? You can either buy a PlayStation or or the Xbox. I have no issues. That means I'm happy with the purchasing of any of the PlayStation, okay? So that means both, if I say I need to purchase both, they'll not be the mutually exclusive events. Since I have given a choice, I've given the options that either PlayStation or Xbox, any any of them can be bought. I'm okay with that. That means it's a mutually exclusive event because both of them are not happening at the same time. Either I'm going with PlayStation or I'm going with Xbox. Okay, same is the case with an odd number will come. So both are not likely to occur. Understood? But most importantly, why I'm focusing on these two words, either and or, because these are the most important. They are the pop-up points. When you see, you'll easily identify it's a mutually exclusive event. And what you'll be doing, you'll be adding up the probabilities in that case. Understood or not?
Sorry, can you repeat that? Your voice cut off.
Okay. For mutually exclusive, Ezra, the words that I have written over here, either or, whenever you'll see in your examination in any question, either or is coming over there, that means it is very much evident that the events are mutually exclusive. Why? Because in these events, there is a choice, either or. When there is a choice and not all events are occurring at the same time, that means your events are mutually exclusive. And then in the end, you will be resulting in adding up the probabilities. Understood?
Yes, sir.
Okay. Now, we can also solve probabilities using Venn diagrams. So I'm sharing just 3 Venn diagrams. Copy them down and then we'll start, okay? I'll give you an example then. Please copy these 3 diagrams down.
Sir, done.
Okay,
Done, sir.
good, 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 good. Okay, so if you notice in the first diagram, A means simple set A, okay? But when you put this complement part, that means not A. All elements except for A, okay? Now it comes A union B. That means all those elements that are in A as well as B, okay? Then you have intersection. Intersection means only those elements that are that are common in both A and B. But if you do like this, all elements except for those that are common in both A and B. Understood?
Yes, sir.
Please try to solve it. Okay, Harsh. Good. Harsh, Khizra, you done?
Sir, I'm on the last one.
Okay. Okay. Questions. Okay. Since you finished, Harsh, you start these questions. Okay. Just a hint for this second question. Please use Venn diagram.
Okay, sir. Uh, sir,
Yes.
I just joined my iPad because
Just a
my
minute. Just a minute, Harsh. Just a minute. Just. Yes, sir. Sorry. Yes. Oh, okay. 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 No problem. I share the two questions. Please solve them. Yes, Harsh. Can you hear me?
yes, sir.
Great. So solve the two questions, please.
Sir?
Yes, Khajra.
Sir, how do you solve the second question?
You want me to solve it?
Yeah, the second one.
Sure. Wait. Okay, as I gave a hint that you people can use Venn diagram to solve it. Wait. See, there are two types of participants. One who owns a desktop, the others who own a laptop or both. Okay. Sorry. Desktop, laptop. Now, what are the percentage who owns both? They are 0.15. Okay. 0.15. Now, my question is that it is written 50% of the participants own a desktop. That means this whole circle is of 50%, out of which 15 is already written. So the left is 0.35. That means 0.35 are those who own desktop only. For laptop, 60% is of the whole circle, out of which 0.15 is already consumed. So 0.45 are those who own a laptop only. Got my point or not?
Yes, sir, I got it.
Now examiner says find the percentage of those who does not own either a laptop nor a desktop. So these are those participants that are out of these Venn diagrams and they are here, X. Got my point? Now,
Yes, sir.
whatever the probability is, the remaining is always equals to 1. So I would say that 0.35 add 0.15, add 0.45, and add x, all will be equated to 1. So if I add all of them, I'll be getting what? Can anyone tell me? I think 0.95. 0.95 plus x equals 1. X will be 1 minus 0.95. So 0.05. That means 5% of the participants are those who neither owns a laptop nor a desktop. Understood?
Yes, sir.
Please do the third question.
Sir, for the second one, for the apples, I got 17/35. Is it correct or no?
The third one?
Yeah.
No.
Okay.
So you want me to solve it?
Yes, sir. Please.
Okay, no problem. Yes, Nizra.
Sir, can you solve it?
Sure. See, first of all, if you both focus on the Venn diagram, okay, let's read it out, okay? From apples and cherries. The following Venn diagram shows the number of children that like each type of fruit. So it's very much evident, okay? If I just read out this Venn diagram. So one child is one who likes all the fruits, apple, banana, and cherries. However, 7 of them are those who likes apple and cherries, and so on, okay? Find the probability that a randomly selected child likes apples or bananas. Okay. Likes apples or bananas. Okay. See, can anyone tell me what is the probability that he likes apples? See, for liking the apple, you have a round figure of 17 because 17 is the total of apple, if you see. So 17 over 40, either and or, okay? See, the word or is used over there. So the probability of banana is 8 over 40. I'll add them both. But there is a problem. What is the problem? See, the children in 17 also includes the one who likes bananas as well as cherries. I don't want that. I don't want that. So what I'll do now, listen. Now what is happening? What is common in both apples and bananas? If I'm not mistaken, there are 4 children that are common in both apples and bananas. If you notice, the 3 and 1. Am I right?
Yes, sir.
So I'll subtract the common part. Can you tell me what's the answer? I think it's 21 over 40. This is how you'll solve it. Got my point?
Yes, sir.
Good. Let's do one more question. Just a minute. Question 8 and 9. Please.
So is it 36 for the question 8?
Question 8.
Yes.
Can you show your working, please?
Sir,
Okay.
I got 52.
Yeah, please, both of you share your working. See, if I solve it, right? Wait, I tell you. See, a hamster. Just a minute. Hamster and a cat. Now, 36% of the participants own a cat. That means that complete circle of cat is 36%. Wait, 20% own a hamster but not a cat. That means 20% will come here, not in the middle one. Okay. And 8% own a hamster and a cat. That means 8 will come here. Okay. Out of 36, 8 is already consumed. So I'll be left with what? 28%. Okay. So this will be X because I don't know the number of people, percentage of people who neither own a cat nor the hamster. So it'll be 0.2 plus 0.08 plus 0.28 plus X. All this will be equals to 1. So can you people please add how much is it?
Sir, how did you get 20% for hamster?
See how I got it. If you see, it says 20% own a hamster but not a cat. That means it will come over here. I cannot put it in the middle. Got my point?
Yes, sir.
I think you wrote over here 12%. Am I right?
Yes, sir.
Yeah. Don't write 12%. You know why? Because it is clearly written. Yeah. If it would have been written like 20% owns a hamster, it means this complete circle will be equals to 20%. You can write 12%. Like in the case of cat. Understood? Either examiner will use the word only or he'll say but not this or not that. So you will use this thing which I used just now. Understood?
Yes, sir.
And tell me what is the total of this?
44%.
It's 0.56. 1 minus 0.56. Yeah, 44%. So 44% of the participants are those who own neither a cat nor a hamster. Got my point? Please move on. Okay, I think you people can solve it and share the working with me, okay? Okay,
Yes, sir.
take care. Bye.
You too, sir. Thank you.
No problem. No problem.